Hello and welcome to today's seminar in the Smart Mobility Connection series. My name is Harja Shahab and I am the Traffic 21 Women in Transportation Fellow 2020 to 2022. The Smart Mobility Connection series is sponsored by the Traffic 21 Institute and the Mobility 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It is also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note this session is being recorded and all participant microphones are muted. To ask a question, please send a message to the box. You do not need to wait until the end of the presentation to send your questions. Here to introduce today's speaker, Allanté Whitmore, and her project supervisor, Chris Hendrickson, Director of Traffic 21, Hammerslag University Professor Emeritus, College of Engineering and Heinz College. Dr. Hendrickson is a member of the National Academy of Engineering, Chair of the Transportation Research Board Division for the National Research Council, and Editor-in-Chief of the ASCEJ of Transportation Engineering. His research is in the general area of engineering planning and management, including design for the environment, project management, transportation systems, finance, and computer applications. Please help me welcome Chris.
Thank you very much, and welcome to the seminar, everyone. Originally, this was advertised as Costa Samaris in Allanté. I'm subbing in for Costa since he was unable to speak today. And I'm delighted to have the opportunity to introduce Allanté Whitmore as her co-advisor with Costa. Allanté is a PhD candidate in the Department of Civil and Environmental Engineering in the Department of Engineering and Public Policy at Carnegie Mellon University, which is a tough row to hoe. You've got to satisfy the requirements for both departments in pursuing a doctorate. Her research focuses on the environmental, equity, economic, and ethical impacts of autonomous vehicles, a very timely topic as there's quite a bit of investment going on in autonomous vehicles. Allanté previously worked for several years in the nonprofit sector as a supervisor, a mentor, and a leader for the McNair Scholars Program at Wayne State University. She earned a Bachelor of Science in Biological Engineering at North Carolina Agricultural and Technical State University, and a Master of Science in Agricultural and Biological Engineering at the University of Illinois at Urbana-Champaign. And we're delighted to have Allanté as a doctoral student here at Carnegie Mellon and also as a seminar speaker today. So I'll turn it over to you, Allanté. Thank you. Oh, I should mention this is a slide that gives a little bit of the history of automated vehicle technology at Carnegie Mellon. It started back in 1984, shortly after I arrived, and the original versions of autonomous vehicles were running around in Schenley Park on the sidewalks. They evolved until now. The 2012 Carnegie Mellon automated vehicle laboratory vehicle was a Cadillac, and you could not even see the sensors on the outside of the vehicle. So with that, I will turn it over to Allanté. Take care.
Yes.
Okay. All right. So we've already done a couple of these slides, so we're going to just move forward with we saw a snap of the video. So essentially, autonomous vehicles are able to sense the same way that humans, well, not the same way, in a way that the same way that humans are able to sense any, whether we use our senses to make driving decisions. What we are trying to do with autonomous vehicles is also using sensors and LiDAR and cameras to help make decisions. But we as humans are still the individuals setting those rules, making the rules for what an autonomous vehicle does when it comes up to a stop sign or is at an intersection. And so when we think about how we are making those decisions and setting those rules, there's been a lot of conversation, and some of my work looks at how we discuss what's the value judgments when we're making those decisions, but also we want to think about the impact of those decisions when we start talking about deployment and the impacts on infrastructure in places beyond just the technical development of the autonomous vehicle technology. So with that being said, there's a robust conversation going on surrounding the impacts, potential benefits and impacts of autonomous vehicles. And there's just a variety of potential responses or things that folks are thinking about as it relates to that. For example, the ideas of the safety of autonomous vehicles potentially being life-saving by reducing fatalities and car crashes, the impact on emissions in our environment as it relates to congestion and traffic flow, being able to, by results of having fewer crashes and having an improved traffic flow, increase productivity, economic productivity in our country and globally. And something that's really important to us is improving the mobility of those who are physically unable to drive or unable to drive for any other reason. Alternatively, folks are concerned with what if those impacts, people are naturally skeptical of those potential benefits. What happens when all the vehicles are either unoccupied and folks are using their AVs to drop themselves off at work and drive back to their home? When we also do have that increase in VMT from individuals who have been currently left out of travel and mobility as a result of their physical abilities, and that we might have an increase in VMT that results in more congestion, more emissions. Those things they have a potential to have a negative impact as a result of deployment. And also about the issues about equity. Who's going to benefit from AVs? If it's only left up to your ability to afford the technology, does that mean you are now left out of the potential benefits, the life-saving benefits, the productivity benefits from the technology, or even the ethical impacts and even workforce impacts for those who are employed by the transportation sector? So what we believe can potentially help us capture more of the positive benefits of autonomous vehicle technology and autonomous mobility is by sharing this technology. So when you think about, maybe about five years ago now, when Uber first had a autonomous vehicle service in Pittsburgh, that service was not shared, but many of us are comfortable or familiar with like Uber Pool or Lyft Line, which is the shared pooled rides. We believe a system like that, where autonomous vehicles are being shared through some digital network, it would not only lower costs, but also provide that more equitable distribution of the technology while helping us again capture some of those more positive benefits. Alternatively, there's autonomous shuttles. These are mini buses that typically can fit around, they're typically built right now around 12 to 15 passengers can ride on a shuttle at any given time. And there are a lot of deployments that have taken place in our country as well as globally that have put autonomous shuttles to practice, especially as a proof of concept for how autonomous technology can be in our system. But many of them are on campuses now, retirement communities where they have a prearranged space that they are providing service, but they exist and they start to have pilot deployments that are taking place. So meanwhile, we have this new opportunity with shared autonomous mobility, but we still have an existing transportation infrastructure, right? Public transit agencies exist and they provide mobility services to everyone, but they uniquely serve the transit-dependent rider, those being individuals who have no other way to get around. So in a survey by the American Public Transportation Association a few years ago, when asked some of their riders if they would be able to go to handle their business without public transit, 25% of the respondents said no. So this is a population that relies heavily on public transportation, needs public transportation for social, educational, and job opportunities. And transit agencies have already a mandate from Title VI to provide service and make sure that whenever they're adding any new transit service, they are not negatively impacting low income and or minoritized populations. So two measures that we focus on in this work and that I want to just establish as we continue this conversation and this presentation, first is transit coverage. So transit coverage is a level of service measure that looks at the entire transit system to determine across that system how much of this transit system is actually providing service across that like geographical space. And transit equity and access, we're looking at where is that service taking place, who's going to be impacted by it, and specifically the two groups we're looking at, well, three is transit dependent riders, low income population, and the minoritized population. So we understand that shared autonomous mobility can provide these positive benefits. We know that public transit agencies still exist, and we don't want public transit agencies and shared autonomous mobility to compete. While that's a potential option, alternatively, we can integrate autonomous vehicles and shuttles together and using autonomous technology to improve existing transit systems and to add service to these systems. But we probably can't add 5 fleets in Pittsburgh and have the same impact on equity and access and transit coverage in New York City, right? There's going to be some differences likely, and we want to know what kind of parameters are necessary, what kind of characteristics does each city have that determine suitability for autonomous vehicles or shuttles. And hopefully we're hoping that we can potentially glean what we need to be thinking about, what agencies could be thinking about when they're considering integrating public transit with autonomous vehicles or shuttles. So that leads to the research questions for our project. We want to know, again, about those different size cities and systems. Can they use autonomous vehicles and to cost effectively improve transit coverage? And what are the unique characteristics for these cities that we need to think about when we're talking about suitability for this new technology, especially when we're considering integrating it with public transit? So I'm going to provide just a quick overview of the methods, and we're going to go into these a little bit more detail. But essentially what we did was we built a model that covers 4 major tasks to uncover the costs of operating a bus, shuttle, or SAV to a census block group. And then we perform some sensitivity analysis to reveal those parameters that are most important for autonomous vehicles or mobility in integrated with the public transit system. Okay. So census block groups are a really important geographical unit that I'll be sharing for the rest of the presentation. They're typically anywhere from like 600 to 3,000 people in a given census block group. And the reason we're using this particular unit for this geographical unit is because it allows a really high resolution analysis, especially when we want to look at low income and minoritized populations. Higher levels of measure sometimes can aggregate these populations where they may not show up. So that's why a census block group is really important. And what you see here is just a graphic of Allegheny County, where Pittsburgh is located, and you just have an idea of like what I'm talking about, so you understand a point of reference with the CBG as I'll be referring to it moving forward. Okay, so with first task for the model, we want to identify or understand the transit supply. So at any given census block group, how much transit is that particular census block group seeing? And that is a combination of the bus stops, the routes that are serving that census block group, and the frequency of the service. So we use this value and we also combine it with our vehicle counts. We want to see how many zero vehicle households are in the census block group. What's the driving population for that census block group? And that will give us our transit dependence score. And we combine these two scores for a transit coverage score. So we want to see where is there an area for a census block group where there are a higher concentration of transit dependent riders that they might have an unmet need as far as transit service. So here again, this is the same county. This is Allegheny County, where Pittsburgh is located. And what I'm showing you here is transit coverage. So if you look kind of in the areas that are dark blue, these are areas that have greater than average or greater transit service. So that means they have sufficient service given their transit dependent population. And in Allegheny County, that looks like 2 routes are serving any given census block group, services about every 10 minutes. And within a quarter-mile radius of that census block group, any rider has access to about 30 stops. Now, when we look at our low transit coverage census block groups, and these are areas that have more transit dependent riders, they are experiencing just 1 route service with 1 route. Service is about once per hour, and there's only like 4 stops in the quarter-mile radius. And so this means that individuals who need the service are also experiencing less than optimal service. And we really want to make sure that they are able to get where they need to go, especially if they rely solely on public transportation. With that being said, we have this understanding about transit coverage. We want to know, for the individuals who are in these areas, are they also low income and or minoritized? Does that mean that we have an equity issue here that needs to be addressed, and maybe a place where we can prioritize our efforts for this new technology? So we do this by looking at EJ screen data. This is a data set from the Environmental Protection Agency, and they provide, for every census block group in the United States, they provide information about, so many things, but what we're focused on is the minority population and low income population. And we overlay the census block group kind of socio-demographic profile with our transit coverage to see where we need to prioritize this new service. So this is the equity designated census block groups in Allegheny County. So every purple blob you're seeing here is these areas have greater than average low income and or minority populations in these census block groups. And the reason that this becomes important is because, again, we're looking at kind of an average census block group. The low income population is about 32%. But when we start looking at our low transit coverage census block groups, that percentage actually increases to 55%. At the same time, when we're looking at the average census block groups for Allegheny County that has our average amount of transit coverage, about 23% of that census block group would have a minority population, but it does double to 46% when we start looking at our low transit coverage census block groups. So what this is telling us is, if we are going to we want to improve access, we want to also improve transit, we want to improve transit coverage for our transit dependent population and those individuals who are transit dependent and or low income and or minority population, we should put our attention in these particular areas, and I'm going to call them priority census block groups, where we're going to actually then see how much it costs to operate these new modes in these areas. So that takes me to the third task, where we are doing a spatial network analysis, where we look at the routes and bus stops for our priority census block groups, and we pull point estimates about the cost of autonomous vehicles and shuttles, the cost of energy, be it electrified or gas or diesel for our 3 modes. We look at operator costs. We look at we look at all these costs, and what we determine is a levelized operating cost in cost per passenger kilometer traveled and cost per vehicle kilometer traveled. And these are 2 common measures so that we can say, okay, if we want to move a rider that's in priority census block group 1 kilometer down the road towards their nearest transit stop, it costs X amount of dollars. And we can look at the cost for buses, we can look at the cost for SAVs, we can look at the cost for shuttles so that we can make an even comparison between the 3 modes. Okay. So in Allegheny County, we found that shuttles and SAVs overall for our priority census block groups are operating at a lower cost, levelized cost than buses. And if we know this is useful and important information because we are able to then see like So we're able to look at these costs and we know that we can, if it's operating at a lower cost, we can then see if there's any parameters that influence these results. Which takes us to the last task of our model, where we perform a Monte Carlo simulation and sensitivity analysis to reveal the parameters that most influence these values, and also to see if we were to kind of tweak different parts of our cost model, if we still kind of arrive at the same numbers, the same costs, and just to kind of help confirm our values that we found for our priority census block groups. So it's a bit of a spoiler alert from our results because we'll be using the same 3 parameters when we look at our other cities, but sensitivity analysis does reveal 3 important parameters, first being the annual distance. So for our cost per vehicle kilometer traveled, that's our annual kilometers. For our cost per passenger kilometer traveled, that's our annual passenger KM. Our fleet size is really important for suitability as well as operator hours. So when we looked at the best case scenario, so when are shuttles and SAVs going best serve in Allegheny County, so of our priority census block group, we actually found one census block group that is best suited for shuttle service in Allegheny County. And we look at, again, those 3 parameters I just mentioned, the route distance, the fleet size, and operator hours, to see how much, what kind of like the characteristics for that service look like. And so it's the distance between the census block group to the nearest transit stop is about 5 kilometers. And we have our revenue kilometers, our operating hours is about 6 hours per weekday, and only requires 1 shuttle to service that census block group with a 40% improvement in transit coverage score, Or there were 4 census block groups that were best suited for SAV service in Allegheny County. And again, the route distances are a little bit further. So they're like from 4 kilometers to 7 kilometers to and from the transit service, to and from the census block group to the public transit stop. And we have like this range as far as the annual revenue kilometers and our passenger kilometers, and a fleet size that did not exceed 2 SAVs for this service, with a 30% improvement in transit coverage score, on average. So now that I've explained the entire model and you understand kind of how each piece kind of comes together for telling a story about the characteristics of transit service integrated with autonomous vehicles, the costs associated with it, we wanted to look at different cities, again, to understand if there are any differences for different systems, and what happens when we have different conditions for this model. And the next city we picked was New York. And even though New York City is, known, it's the largest transit system in the United States, and really, really thorough system, there are still gaps in transit service for the transit dependent populations. It's a little less concentrated as you might have seen in Pittsburgh, where there are kind of small sections and neighborhoods that still have some unmet transit need, which are the darker brown colors. But then I think people can find that surprising because we know New York as a place that really does have like a lot of transit service. And in New York, it's a very diverse area in every sense of the word as far as diversity goes. And there's a really large transit dependent population, which also makes sense because it's such a robust system. But we have that same finding as we found in Pittsburgh, that when we look at our low transit coverage census block groups, that low income and minority population is larger. So that means we need to make sure that we're prioritizing service in these areas. And the same with, like I said, with the minority population. In our average census Block group, the minority population was about 60%, whereas it jumped to 90% when we looked at our census Block groups with the lowest transit coverage in New York City. So the levelized costs actually went kind of in different directions as far as if we compare them to our results from Pittsburgh. Our cost per vehicle kilometer traveled, so this top row, they actually increased. So across the board, the cost to provide the service per vehicle kilometer is much higher in New York City than it was in Pittsburgh. Alternatively, in the cost per passenger kilometer, it decreased because there's a higher density of passengers. So the service is actually moving for more passengers. It's moving more passengers over within its operating time, whereas the distances are actually shorter for service between a priority census block group to a nearest transit stop in New York City. So 15 of the 107 census block groups in New York City were best suited for shuttle service. And like I just said, those route distances were a little bit shorter. So it's a little bit over 2 kilometers that any given shuttle would have to travel to provide a first and last mile service from the nearest transit stop. We see a little bit of a wider range with the revenue kilometers, and even more passengers are able to have this service because the operator hours are much greater. This is service for an entire day, whereas in Pittsburgh, to be comparable with the service surrounding that census block group, it was maybe for the peak hours of the day. Still here, we see no more than 2 shuttles, and there's still, about 24% improvement in transit coverage for these 15 census block groups. Next, our SAVs were the most cost-efficient mode for 4 of our census block groups in New York City. Again, that shorter distance, but we do have a little bit of a wider range for our revenue and our passenger kilometers. We're operating most of the year, but in New York City, there were all of the priority census block groups that were going to have service with SAVs only needed 1 SAV to provide that service. And we also found a 23% improvement in transit coverage. This was really interesting because there were areas in New York City where 1 bus might be able to provide that service, but it would take the equivalent of like 3, 4, 5, 10 SAVs to provide that service. So finding these 4 out of the 107 census block groups was really interesting and really provided some more insight. So we did look at other cities, but for brevity, I wanted to kind of give the comparison between our mid-sized city of Pittsburgh and New York City, which is a really, really large system. And we were able to compare the metrics from each system, compare the annual distances and the annual passenger KM, the fleet size and operating hours to find essentially like suitability or feasibility ranges for SAVs and shuttles. And we found, I don't have to go through each bullet, but you see that there's this range that we now have an understanding about the SAVs, the shuttles, our fleet size not exceeding 2 SAVs or shuttles for any given CBG and across all of the cities, and operating hours can be for the entire day. So what does this tell us? What's useful about this information? What can we do with it? We now know that for SAVs, a lower passenger kilometer and vehicle distance are really important. So SAVs are going to be most cost efficient when density is lower and the vehicle distance is relatively low, whereas shuttles can handle a wider range of first and last mile trips than an SAV, given the passenger capacity. And they might be a good intermediate step between an SAV and a shuttle, an SAV and a bus, which then is going to handle our really big and high density trips in a city, for example, like New York City. There are still capacity limitations. There is a point, a tip over point where buses are no longer, where shuttles and SAVs are just not feasible for service. And there's going to be times when a bus is still going to be the better route, the better mode choice for improving service in some areas that have that higher density. And in the alternative, if someone was to say, well, that's fine, but we still want to use this new technology, then there becomes an issue about fleet size. And we start to think about road utilization. And if we have more shuttles and SAVs on the road, then we're actually contributing to congestion, and we want to avoid that. We want to really get the positive contributions from the service. And lastly, that in all cases, the addition of transit service always improved coverage and equity for each city. So as I conclude, prioritizing equity provides a win-win for transit agencies and riders. Our riders are getting more access to all of the opportunities that are available to them and better service, which makes them enjoy their trips in public transit more. Transit agencies are furthering their regulatory compliance with transportation equity. They are, by improving equity in that way with autonomous vehicles and shuttles. Also, shared autonomous mobility, we understand, does not work under every scenario. And as such, we can constrain service about where service is taking place, how service is taking place, so that we can glean and pull the most positive impacts from integrating public transit with autonomous vehicles and shuttles. And we really want to make sure that if transit agencies are going to move forward with the service, that they are, again, creating those constraints around the distance or the operating hours and the fleet size to maintain that cost efficiency, to improve equity, and to maintain a complementary service of the technology versus competition. With that said, I want to thank you all for your patience during our technological issues. Thank you for your attention. I am so excited to answer any questions you have about the work.
I have lots of questions for you, Allanté.
All right.
The first, can AVs ever be guaranteed to be 100% safe? If not, what level of safety, or perhaps more accurately, error, is acceptable?
Thank you for the question. So I don't know if anything that we can do as humans can be 100% safe. And there have been studies that have looked at the amount of time it would take an individual, not an individual, but for us to test the safety to be that equivalent to the amount of miles that we've tested with vehicles. And it would take tens to hundreds of years to kind of reach that equivalent. And so it becomes a trade-off between, do we figure out, do we assess the safety and, determine a threshold? I don't know if I'm the person to determine what that actual value is, in exchange for delaying deployment and experiencing more fatalities and death from human error. So I think I offer more so a thought versus an actual a decisive answer, but that's just something that I think individuals are thinking about and considering in terms of safety, and that I think that we have to figure that out at some point.
Okay, do you use 4 steps modeling to planning the implementation of SAV?
Do I use 4-step modeling to read that for me?
Maybe plan the implementation.
To plan the implementation of SAVs. So I use the same 4-step model that I shared with you, the method I showed with you all for each mode. So that's taking place for every mode. And we want to see how the costs and the parameters that influence the result. Hope I answered your question.
Okay, for the data used, public transit bus operations versus SAVs and shuttles, are buses operating on fixed routes, whereas SAVs and shuttles are operating as on-demand services?
So it's the shuttles, SAVs, and buses, it's as if we are going to add the service as a first and last mile solution. So essentially we have, a census block group that has that need. And so we're going from that census block group to the nearest stop. So they're actually all operating in a fixed route way. That's why we have the operating hours that determine the frequency of the service for all three modes.
Okay, are the capital costs for the SAVs and shuttles based on current costs or anticipated costs after further technological and supply chain efficiency gains?
Right, they're current. So we've been working on this for a while. So we make sure to update the costs if there's an update to the cost of the technology, but we acknowledge that there's a potential for a lower cost in the future, which means that our results would mean even more savings for SAVs and shuttles compared to buses. Thank you for that.
How do you think the pandemic will affect public transportation ridership over the next few years?
Over the next few years, that's a good question. I would need to reflect a bit on that. But my initial response, I know right now that the agencies are, have been hit by the pandemic and the decline in ridership, and therefore they're working with different budgets, smaller budgets than they were in the past, in addition to just the fears that people have about sharing spaces with other individuals. And I think that there has been an effort towards, with wearing our masks, to make people more comfortable with public transit again. I don't know that I'm nervous to say where if public transit will completely bounce back or not, but I do think that if this is the way that we'll be moving and navigating for the next couple of years, individuals who need public transit are still going to be using it. And hopefully we can create some things that attract people back to public transportation.
Have you looked into how improved public transit in low-income housing could impact housing prices, rental, and ownership? What relationship do you see between AV and public transit and gentrification?
Great. Now, housing is out of our scope. We don't look at housing, but I think that it's a worthwhile question. I would say that if we were to look at low-income housing and gentrification and this kind of the relationship between all of them, I think there would be some interesting findings. But with our work, with the emphasis on equity, I would imagine, and the emphasis on moving this technology to areas that are low income and minoritized, we will find that at least there is access, that equitable distribution of the benefits of the technology in these spaces. Now, I can imagine that makes the space more attractive, or that area more attractive to more people. But I have caution to say what that means, because housing and land use development in that way is not my expertise, but I do think that's something worth studying.
For persons with disabilities, what assumptions were made for first last mile in terms of service distance from home? For example, did you assume that SAVs pick up passengers from the same locations as shuttles and buses, or would they provide door-to-door service?
Thank you. So shuttles, fortunately, many shuttles actually have a wheelchair ramp or something that there's a wheelchair ramp for individuals who maybe are wheelchair users, and it's a lower bus, so it's going to be lower, so individuals with disabilities should be able to get on the shuttle with ease. As far as location, what we did for simplifying the model as well, we have individuals going from the center of the Census Block Group. So individuals are traveling less than a quarter of a mile, preferably, to the from there to the sorry, I got my thoughts mixed up. So they're going from the centroid to the nearest stop, and The hope is that they can travel between the home and their center of their census block group. However, if that's not the case, there would need to be kind of more on-demand door-to-door service, but that was not within the scope of this particular study.
Okay, when you say spatial analysis, what types of analysis did you conduct on the CBGs?
So we're looking at the distance between the census block groups centroid to the nearest transit system, the nearest transit stop. That is a part of the spatial analysis. That's in the third step. So routing from our priority census block groups to our public transit stops. For the second and first steps, we're essentially looking at creating the graphs, and then again, kind of an overlay of our priority census block groups, our low transit coverage with our low transit coverage with our equity designated census block groups to identify those priority census block groups.
Okay. I was wondering a bit more about the equity designated CBGs. I think that they could help us beyond transit. Was this based solely on income or other factors? What all went into that designation?
So the equity designation consists of three parts. It's our transit dependent rider, our low income population, and our minoritized population. However, that metric of equity designation is a piece that I think a lot of individuals are working towards figuring out right now and kind of helping to create a uniform measure, because different cities take and create their own equity indices. So for example, in Pittsburgh, it includes like English as a second language, single parent households or women-led households. There's also like immigration status that also are embedded into their equity index, whereas another city might have a totally different definition. So that was our definition. However, there are, like I said, efforts being made towards kind of creating a uniform equity measure for all systems in the US.
Is the distance traveled to and from storage areas for the SAVs and shuttles when not in use or for cleaning and maintenance included in your cost calculations?
So what I shared today was the revenue result, so our revenue kilometers, but we do have our total kilometers included that do include the storage and going to, I don't necessarily include like maintenance, like time for maintenance, but definitely to and from our garages in Pittsburgh.
Will transit authorities directly provide the shuttle AVs to bus and transit stations? If yes, will it eliminate other competitors like ride-hailing services?
So the way that this paper and this project was organized, that's absolutely correct. So autonomous vehicles or shuttles are going to transit stops. We did not look into the impact on TNC's existing micromobility options. And I think that would be something worth studying and exploring. Thank you.
Why doesn't the research use the car ownership rate in CBG, but focus on the minority population, which I perceive that is based on race, not income instead?
We include all three. I think if I understand the question correctly, they're asking why are we using why aren't we using vehicle ownership?
Correct.
Right. So we did use vehicle ownership. That was in the first step. And then we wanted to see, as it relates to vehicle ownership, and what percentage of this population is also low income and minority. So we are using all three factors in our study.
Do the per vehicle mile costs displayed include the presumed capital cost of the vehicle over its operating lifetime?
Yes.
Or is the cost per VMT figures purely operating cost?
So we do include the capital cost, assuming a 10-year service life in the bond rate for the state of Pennsylvania to create like a annualized cost. And that's included in our cost per kilometer and our cost per vehicle mile travel. Passenger kilometer travel.
Okay. What has surprised you the most about what you have learned through your research?
What has surprised me most? I think I might have come into this work hoping that, I think as the fact that I think I assumed SAVs would always be the best choice for every city and every time. And so understanding that there's kind of like these bands or these ranges where the shuttles are a really good stand-in and they can really provide a better service than SAVs was a bit surprising for me, especially because SAVs they're a 4-passenger vehicle. I feel like they'd be a little bit more flexible than a shuttle, but that's, as I've found out, not always true. So I thought that was really interesting.
And I have one more. Could you please elaborate on or re-explain how you came up with the operation costs for electric AV shuttles and SAVs?
Sure. So we did point estimates for the maintenance cost, the energy cost, the annualized capital cost, the charger cost for shuttles. We included, I'm trying to make sure I don't forget any of the parameters we included. We also have the operator costs, and we pulled these values from other literature, from companies, manufacturers, and we were able to combine all these costs to get into our operating costs. Can you read the question for me again, Joy? I want to make sure I answered most of the.
Sure. Could you please elaborate on or re-explain how you came up with the operation costs for electric AV shuttles and SAVs?
Yep. So like I said, with electrified shuttles, we did include the charger cost and annualized charger costs and the cost for charging the vehicle, electricity. And with the SAVs, we had our annualized costs, our operator costs, our maintenance costs, all of those. And then we looked at the annual distance for any given census block group to find our levelized operating costs in our 2 measures.
That is, oh wait, I have one more, I'm sorry.
Sure.
What policies should city DOTs look at for optimizing their roadways for AV transit vehicles?
So that is kind of one of our findings, right? That annual distance is really important. The fleet size is really important in the operating hours. And so state transit planning agencies can create, I would think, constraints, say, about where those services are. So if they want to use this prioritization framework of they need to be areas that have an existing transit need based on transit dependent ridership, based on low income population, based on minority population, or whatever equity factors are really important to that specific city. I think that would be useful and helpful. In addition to that, determining the way that the system will work as far as, again, the operating hours, and then putting constraints on the fleet size. I believe those pieces, and from our work, will help to maintain the complementary relationship between autonomous vehicles and or shuttles and public transportation.
Thank you so much, Allanté. That is all of the questions. And thank you everyone for all these great questions to have Allanté answer today.
So nice to see so many Costas in here.
Thank you, Allanté, for sharing your work. And to all of today's attendees, thank you for joining us. As I mentioned earlier, today's presentation will be posted on the Mobility 21 What's Happening page of the website, along with the link to the video of the session. This afternoon, you will be receiving an email asking you to take a short survey about today's SMC. Please take a few minutes to provide your feedback. For students who are interested in engaging in transportation topics, the Transportation Club on campus is a great way to plug into transportation topics with fellow transport nerds. Our next SMC will be on Friday, September 24th, and will feature Eric Guerra, who will be presenting his project, What the Heck is a Choice Rider? A Theoretical Framework and Empirical Model. Watch for your invitation to join us closer to that date. Again, thanks for attending today, and please feel free to contact us with any questions.